Good morning or good afternoon, everyone. It's Carl speaking. On behalf of Mr. van der Bank, I'll be taking his presentation that he did for us in the one practical class, where we did practical 2, part 1, and I'm going to try and make it a bit more concise. Just some notes before we get started. Everything will be done in Excel, as I do not make use of SPSS, but if you are more comfortable making use of SPSS at certain points, by all means. Alright, so let's get right into it. This is practical 2, norms and prediction rules. This is part 1, calculating the norms and prediction models. So here we've got a little case study which says the data set includes the criterion, in essence job performance, and test performance of spur waiters that were collected during a validation study. Job performance is measured by 360 evaluations done by managers, other waiters, and customers. Each waiter was tested on 4 different employment tests, the first being extraversion, the second being agreeableness, those two being personality traits, the third being memory, one of cognitive traits, and lastly English proficiency. So the following calculations and analyses are required of us. We see that there are 10 steps that we need to progress through, and this video will try and address each one of those as concisely and as accurately as possible. Question 1. Calculate the descriptive statistics for the criterion and all predictors. So first of all, the criterion is, as we mentioned here, job performance. And the predictors we see here are extraversion, agreeableness, memory, and English proficiency. So I'm going to take us over to the Excel spreadsheet now. Please don't be concerned if you see a lot of stuff that you don't have just yet. At the end of this exercise, you will have all the data necessary. Alright, so our first thing that we need to do is to calculate the descriptive statistics. So descriptive statistics basically just describe our data, and we usually make use of average or mean. We make use of standard deviation, minimum values, as well as maximum values. We will see here that our dimensions include performance, which is our criterion. We have extraversion, agreeableness, memory, and English as predictors. Alright, so for the purposes of this tutorial, I'm only going to be showing you how to do the calculations and not necessarily going to be interpreting what each of them means. Alright, so if we look at the average or the mean, the formula used to do so is equals average, and then you include your data series that you want to make use of. So as we can see here, if I were to quickly do this, alright, so we want to see what the average is of performance. Alright, so we go here, we click under performance, and then there's a nice little shortcut if you're interested. One way of doing it is either to scroll down to the end of the data series, which could be considered a bit time consuming. Another easy way of doing it is to go Control, Shift, and down arrow, which will take you to the end of your data series, followed by brackets and enter. There we have our average or our mean for performance. You can duplicate this process for all the others to inform your averages or mean as well. In terms of standard deviation, the formula that we will be using is stdev.p, and again using the same dataset value. So we're going to be going again from B2 all the way down to B151. Alright, you can do that as well for the others as such. And then very straightforward, minimum and maximum values, strictly min within the data series that you're interested in, as well as max the data series that you're interested in. Alright, this concludes question 1, as we do not need to interpret the descriptive statistics just yet, but merely had to calculate them. Question 2. Convert the raw scores to standard scores, specifically referring to z-scores, stenines, and percentiles. Alright, so I'm going to take you back over to the Excel spreadsheet, where I think it is very nice for us to just order our data accordingly. So we want to standardize the raw scores for all of our predictors, in this case referring to extraversion, agreeableness, memory, and English. And specifically we want the z-scores, stenine, and percentile of each. Alright, so let's get started. In order to calculate the z-score, we look at our formula page down here, and we see that z equals x, being our raw score, minus the dash on the x, which is our mean or our average, divided by the standard deviation of x. So when we put that into Excel, we see here we want to determine the z-score of extraversion. So we take C2, which we can see here is Franken's extraversion score, the raw score, minus the mean of extraversion divided by the standard deviation. Alright, so it is also very important to note that at this point you might have noticed that I put in dollar signs. For those of you who can't remember, dollar signs are used to fix the location of your series, the things that you don't want to change and that you want to remain constant as we take it down below. Alright, so again, we've got the raw score. No matter what the predictor is or the thing we're looking at the raw score minus the average or the mean divided by the standard deviation. And because in this instance we made use of fixed values here and here, we want to keep it located at that position, which is $3 and $3, these two here. Once you've done this, you can easily take it down to the rest simply by double clicking on this arrow here, and it will take all the data down instead of unnecessarily having to scroll down all the way down to the bottom. However, it is worth to mention that sometimes at the beginning, when we first put in our first row of data, it is necessary to draw it down all the way to the bottom, because you will see that after this, now we can go, for example, if I were to do it, it's the 9s, it goes down automatically right next to it here at the bottom. Now that we have calculated the z-score for extraversion, we are free to copy this formula, or the thing that we did, and we apply it to agreeableness, memory and English distinctly. Again, just referring to the raw score, in this case Franken's raw score we see is here on agreeableness, which is 130, minus J $4, which is here the average or the mean, divided by the standard deviation of agreeableness, and we get the z-score. And again, we can double click and it should take it down. If that doesn't work, we simply take it down manually for the 150 observations. And you're free to repeat this at the other ones. Then, moving on to STER9s, what is the formula for STER9? We look back at our instructional page and we see that a STER9 is 2 times the z-score plus 5. So, when we put this into Excel, we see that it is 2 times P3, which is Franken's z-score on extraversion, plus 5. You will note that originally when you do this, you might get a value that looks kind of a lot of decimals in it. But when we work with STER9s, we typically want rounded off numbers. So in order to do that, we go to Home, here at the top. We go right here when it says decrease decimal, and we take it down as such. Alright, so you can repeat this process again here at the others, and then double click when you want to take it down to them as well. Alright, let me just quickly take us back here. There we go. Alright, so that covers the STER9s, the z-scores, and now we move on to the percentiles. So in order to calculate the percentiles, we're going to be making use of this formula, which is equals percent rank. The first thing here before this comma is the data series that we'll be looking at, which is our z-scores. In this case for Franken or for extraversion, we start at P3, and then we work it all the way down to P152. You will notice again that we have dollar signs here as we want to keep the data series stable when we take the values down. But you will notice after the comma we want to see how does P3, how does Franken's z-score in terms of percentile compare to the other people's scores. That's why the P3 and P4, P5 all the way down to P152 should be different for each instance, and that's why we can get different values. Also, it's worthwhile to times it by 100 so that we can have it in percentage values as well. Alright, so once you've got the hang of this, simply take it down to the bottom. Once you have calculated the percentiles for extraversion, you can duplicate this process or this formula simply by taking it over and making sure that these values correspond to what you're trying to do. So just to specify, now that we're looking at agreeableness, the data range should be the z-scores of agreeableness. The same will count for memory and English. Alright, I know that sometimes in exams we can be pushed for time or we can feel some pressure on us, but it's very important just to note that when you are copying and trying to save time, that you make sure that these things are sound. And again, it won't necessarily help just to copy the formula, as you need to know where we are finding these values. Alright, this concludes question number 2. Question 3. Describe Franken, Eyre and Blacker or Blasher in terms of standard scores, specifically the normative scores. So when we go back to our Excel spreadsheet, we have now calculated all of these For extroversion, agreeableness, memory, and English, the z-scores, the 9s, and percentiles. They are asking us now to describe them in terms of their standard scores. So basically what we can see here is we can see that for extroversion, when looking at percentiles and the 9s, we see that air is leading a little bit in terms of the two, Franken and Blasher. Then for agreeableness, we see that, whoa, Franken is in the head, is in the lead, as having the highest percentile and the 9. We see that for memory, it's again Franken leading in the head, with Air and Blasher following, but then finally we see that Air takes Franken past English, and we see Blasher is now up to second place. So we want to interpret, or we want to describe them in terms of the normative scores. We can say that we see that for the most part, Franken and Air appear to be our top candidates, in that consistently they are fighting for the top 1 position, and that we see Blasher or Blacker falling slightly behind. This concludes question number 3. Question 4. How will you rank order Franken, Air, and Blacker or Blasher? So, as we mentioned in the previous question, we saw that Franken and Air are both competing strongly for first place, with Blasher only necessarily becoming a competitor in the English subdomain. So if we were to order them or to rank them, one could argue for either Franken or Air, but it's just important to substantiate why you're taking them. So for example, one might argue Franken, in that although extroversion was lower than Air's, we see that for agreeableness and memory, Franken takes the strong lead, and Air, for English and extroversion, only takes a moderate lead. However, on the opposite side, we might be able to argue that Air could be first, because for extroversion, which refers to like the way that people deal with other people, what their degree is of what they prefer, stimuli in the environment, and so on, we see that he is higher. So perhaps Air would be more suitable to work in a busy restaurant. And then again, we can also argue that perhaps because of his English proficiency, or her English proficiency, we can see that they might be able to converse better and to form a better dialogue with their clients. So here we do not have a right or wrong answer. It's all about your interpretation, how you explain your ranking. Alright, this concludes this question. Question 5. Evaluate the criteria and related validity of each predictor and choose the best predictor thereafter. Alright, so we go back to Excel. As you would have noticed or might remember from Mr. van der Bank's class, it is possible to do these calculations in SPSS. I however prefer to do them in Excel, but you're more than welcome to choose your preference. Alright, so in Excel, if we want to look at the criterion related validity, the correlation between our predictors and our criterion, we need to make use of the following formula. Equals correl for correlation between B2 and B151, which is our dependent variable, our criterion variable, and we want to make use of extroversion, which is C2 down to C51. When we press enter at the end, we'll see that there's a negative correlation between extroversion and performance, and you can copy this over for the others as well, just making sure that you remember to update the data series for each case individually. Alright, so when we look at them, we see there's a negative one here, so we're probably going to remove extroversion. We see agreeableness has a 0.509, memory has 0.513, and English has 0.819. English is clearly our highest, and therefore we select him as our strongest predictor. This concludes this question. Question 6. Develop a prediction equation using the single best predictor. Alright, so as you guys may remember from our classes with Mr. van der Bank, we know that the formula for a prediction equation looks something like this. Y equals mx plus c, but it could also be y equals bx plus c. The letters are not as important as the values that will replace them later on. So for the purpose of this tutorial, I will be making use of the traditional y equals mx plus c formula, and now we want to put in the data. So, as you may remember from our previous lessons with Mr. van der Bank, we know that in order to determine the prediction equation, we need to do a multiple or a linear regression equation. Alright, so again, it's possible to do this in SPSS. If that is your preference, you're by all means welcome, but I will be demonstrating how to do it within Excel. You can see here that I've already copied the values, but I'm going to show you how we got these values. So what you want to do is you want to go up here to data, and you want to see here on the right hand data analysis. If we'll put in the end, if you do not have this data analysis thing, I will show you how to put it in, but for now I'm assuming that our Windows or our Excel does have this. So we say data analysis, we want to choose a regression. You'll see that there are a lot of others, but we are only interested in regression. And you see input Y range, X range, all these nice things over here. Okay, so when we say input Y range, Y always refers to your dependent variable or your criterion variable, the one that is to be influenced. And in this case it's performance, because we know we want to see how do these influence or impact on performance. So we want to input the Y range. So we start at B1 and we take it down with Control Shift Enter all the way down to B151, and we want to check labels in that we just included a label. Now we want to do our X range. Our X range is now our deep independent variable, which in this case, as we know, the strongest predictor was English, right? So now we want to see how does it match up with English. So we take F1 and we draw it down all the way to the end of the data series, which is F151, and you can choose where you want it. Output refers to where do you want the all the stuff to be displayed. For the purposes of this workshop of this tutorial, I'd consider it nice and neat just to put it on its own sheet, but I will show you how it looks if we put it inside of our data thing here. Alright, so we look at output range. We want to put it right, let's just put it here below our data series, and we say okay. Now we just wait and we see we have a nice summary output. We see there's a multiple R squared value, adjusted, standard error. Here we see ANOVA, we see the significance of the model, and here we have the most important things. So we've got the intercept, which is 69.276, rounded down to 69.228, and we have English. The correlation between English and performance is 0.47. Alright, so it gives you the summary output here. We have multiple R squared, all these nice values up here. And then again, as for the purposes of this tutorial, we'll not be interpreting these values, but only showing you how to use them. Alright, so the most important ones that we are looking for at the moment are these here. That's why I took the liberty of copying them up here. And you will see that the intercept value, 69.2709, that's why we rounded it down to 69.27, and the correlation between English and performance being 0.47. So now when we put it into our formula, we know that the correlation, being M, or in other cases B, goes in here. So we've got 0.47 times X, X being your raw observed score, plus C, which is your intercept value, and in this case we have 69.27. Here we have the regression or the prediction equation. So basically we're saying that in the end, if the person were to score 20 on their raw score for an English test, we are likely to see that they will score a Y, which is their performance at the end. This concludes this question. Question number 7. Use the single predictor equation to calculate the expected job performance for each applicant. Alright, so what we want to do is we want to basically take this formula that we did here and put it into practical terms. So for the moment, I'm going to just hide these places here, just to make it a bit easier. There we go. Alright, so what we want to do is we want to determine the predicted performance using the single predictor, which we decided to be English, and we want to determine this for all of our participants, right? So we basically want to put in the values into this formula. So what we have here is basically saying equals F2, what is F2, looking at the observed score, times K18, which we see here, is our correlation, right? And then those two in brackets plus the intercept at the end, which is K17. You're more than welcome to do it in a different way, where you can make use of the actual values. I simply made use of the represented values in these squares. If you were to do it as I did, just remember to put in your dollar signs to keep these values constant. And then you will see as you take it down, all the raw scores change, but the correlation and the intercepts remain constant. This is how we can very nice and easily calculate the predicted performance using the single predictor for English. So in other words, in practical terms, we see that Franken had a raw score of 158 on English. We put that into the formula, and now we can predict his performance as being 143. You will notice that there's only a slight difference with Franken. Ayer's predicted performance is somewhat as a somewhat larger discrepancy between the two, and then we see very similar again with Blasher or Blacker. Alright, this concludes this question. Question 8. Develop a multiple regression equation. Alright, so when we go over to Excel, we may have noted that in a previous question we used a single predictor equation, which we have here using only English. However, as you may recall from Mr. van der Bank's class, using only one predictor will not suffice in giving us the most accurate predicted score of performance. So what we want to do, we want to see how do the other predictors weigh in together with English to inform our predicted score of performance at the end. Alright, so as we mentioned earlier, because extroversion's correlation was negative and quite low, we're not including this in our model at the point. Although there was some point of contention in the class regarding this, for the purpose of this tutorial we excluded extroversion. Alright, so again, now we want to do a regression formula again, and the only difference this time between what we did the previous time and now is that we again go to data, you go to data analysis, we choose regression. Our input range for y, which is our dependent variable, stays the same. It's our criterion variable. And this time only the input x range will differ, where we want to make use of everything. Agreeableness, memory, and English. And we want to take it down with Control, Shift, down arrow. We want to make use of labels, and now we just want to choose a different output range. This is basically where it's going to throw us all the stuff that we just wanted, and we're going to put it somewhere right there. Right? And we say OK. We will see now that there's a lot more stuff presented here, but again the most important stuff for us is to consider multiple r and r squared. As you remember from Mr. van der Bank's class, he does interpret this. I will not be going into too much detail. He also looks at the significance f. As we can see from this value, it's far below 0.05, and then here's the most important stuff that we want. Right? So we do this, we copy this, and we take it right back up here for ease of use. Then we see it's the prediction equation, agreeableness, memory, and English, and performance. So how do these guys compare with performance? So we see again this intercept being 51.22, but now instead of only having one m and one x, we have multiple m's and multiple x's, as you will see from this confusing formula down here. Right, so agreeableness being our first variable and our first predictor gets the value m1 for the correlation. Memory subsequently gets m2, these values corresponding, and English getting a 0.367 m3. So we want to put this into our formula. So basically we'll say that y equals m1, which is 0.2 times x1, which is the observed score under agreeableness. Then we say plus 0.227, which is our m2, times x2, x2 being the raw score on memory. And then finally we have plus 0.367 times x3, x3 being our raw score on English. Ultimately we want a plus 51.22, which is our intercept. This little c value here that we need to remember, and this will give you the multiple predictor equation. This concludes this question. Question number 9. Use the multiple predictor equation to calculate the expected job performance. This is basically the same as number 7, except that now we're going to be using our newest predictor equation to see if we can't find more accurate results. Right, so now we're going to want to put in all these values, all of the raw scores for each one we want to put into them, and we want to make a formula of it. Right, so again, now we see it looks a lot more complicated than it is. We see D2 referring to agreeableness, the X score. We see K$26, which is this one here, which is agreeableness's correlation with performance. Then we go over to the next one, which is plus E2, now referring to memory's raw score times memory's correlation with performance. And then finally we want to say plus the raw score of English times the correlation between English and performance being 0.367. Ultimately plus the intercept value of 51.22. Again, take notice that because I did not make use of the numerical values, one has to put in K, dollar, and then whatever the range that you're using. Again, making sure that we want D2, E2, F2 to change, the others to remain constant. Also, I just quickly give you an example. If you were to have made use of the numerical values, so basically what we want to do is instead of saying K26, we say D2 times 0.2 plus E2 times 0.227 plus F2 times 0.367, and then finally plus our intercept value of 51.22. You see, we get 153.82, and if we take it down, all the values will be exactly the same. You're more than welcome to choose whichever one you prefer. Now we have the predictor performance using multiple predictors as well as the one using only English. This concludes this question. Question number 10. How will you now rank order Franken, Eyre and Blacker or Blasher? Which one of the candidate or candidates would you consider selecting if the cutoff score of the criterion job performance is set at 115? So you can see there's two questions here. How will we rank order them, and who will you select based on this 150 cutoff score? Right, so when we go over to our Excel data, we see here these are the performances of our candidates, the ones that they are requesting us to look at. You can just give it a nice color there. Alright, so now we want to rank order them. We see now that Franken is again in the lead with 153, following very closely as Eyre with 152, and Blacker or Blasher falling slightly behind at 142. So if based on these values we would rank order Franken to be first, Eyre to be second, and Blacker or Blasher to be third. Alright, but the second part of the question says if there was a cutoff score of 150 for the job performance, who would you select if there's one or more? We can confidently say, based on our predicted outcomes or of our predicted performance scores, that both Franken and Eyre are appropriate candidates for the position, and these two are clearly past the cutoff score of 150. This concludes question 10. Alright, to conclude practical 2 part 1, I'm just going to give us a brief summary of what we accomplished today. So number 1, we calculate the descriptive statistics for the criterion or predictors. Specifically, we calculated the averages or the mean values, the standard deviations, and the minimum and the maximum values. For question number 2, we converted the raw scores to the standard scores, in other words z-scores, stenines, and percentiles, making use of both these two formulas for the first two, and then also making use of equals, percent rank, the data series, and the z-score times 100 for percentiles. Alright, then we went over to question 3, which is to describe Franken, Eyre, and Blacker or Blasher in terms of standard scores, their normal scores. So basically we looked at the stenines and at the percentiles, and we tried to see more or less the two, that Eyre and Franken were definitely our top candidates, and that Blacker or Blashers fell somewhat behind. And this led us to question number 4 in terms of how will we rank order Franken, Eyre, and Blacker or Blasher. And we could clearly see that Franken and Eyre was almost tied for first place, with arguably Franken taking a lead based on our speculation. But again, this rank order, it's important to note that this one is not conclusive in that we do not have all the values that we need just yet. This led us to question number 5, which was to evaluate the criterion-related validity of each predictor and choose the best predictor. So based on our correlational analysis that we did here, we saw that English, which had a 0.819 correlation with performance, was our strongest predictor, and therefore we selected that in this question. Then question number 6, we developed a prediction equation using the single best predictor, that of English, and we did this by performing a multiple regression within Excel. You're more than welcome to refer back to see how we did it, but basically we got these values here and we were able to inform this formula here with these values. Alright, Then for question number 7, we used the single predictor equation to calculate the expected job performance for each applicant. So this is what we did. In this little column here, you see we basically just applied their raw scores within that formula, and then we got the predicted performance using only English. Then we went on to question 8, which was to develop a multiple regression equation. Basically, as we know, the purpose of this was to see what would the difference be if we consider all of the relevant predictors, these 3. So in order to do this, we again made a multiple regression equation. Please refer back if you're uncertain as to how we did it. And we wanted to make use of these values, putting them into the y equals mx plus c formula, except considering that as there was not only one predictor, as is the case here, we have multiple predictors, which is why we have the m1x1, m2x2, and so on, plus the c, which is the intercept. So we were able to derive this formula based on the values that we derived from the multiple regression. And that concluded question number 8. Then for question number 9, we used the multiple predictor equation to calculate the expected job performance, which we did here. Basically the same as we did with a single predictor, except that we had to put in a bit more raw score values or observed scores into our formula. We also looked at how you can do it either by means of making use of fixed values, or you can put in the numerical values yourself, just as you prefer. And then finally we looked at how will you now rank order Franken, Ian, Blasher, which one of the candidates would you choose. We said that, well, based on this one, we rank them as they come, Franken first, Ear second, and Blasher third. And also if we had to choose them, candidate or candidates, we choose these 2 as they were above 150. This concludes this tutorial.